Okay, so you found the two roots for your equation were 6 and 2, so what do you think that means?
Well, I don't think it matters which is which, because whichever one's 6, the other one's going to be 2.
Okay.
But for the way I drew it, I'll make this 6 and this 2.
Okay.
So, you're going down 2. This is 4 minus 4.
Okay.
And here you're going over 6.
All right.
So, minus 2, minus 4.
All right.
So, then this here is 2, 4.
All right. Nice job. You found the coordinates. You're a little bit of calculating. Now, you did make some really good symmetry arguments. You found two unknowns, you've connected them through some equations. But let me ask you a couple questions. You see your big square here?
Yeah?
You knew this x-coordinate was 4.
Yeah.
Do you see the y-coordinate there?
I mean, just without A and B?
No, this coordinate here, it's 4 comma minus 4.
Yeah.
How do you think you could have seen from a geometric argument that this corner here was 4 minus 4? Just from the geometry.
Well, without knowing that this was 6.
Right, without doing any calculating. Once you had this square, we knew something
Well,
in the geometry that would have told you that this was 4 minus 4.
well, because it's this. There's a line from 0 to 0.
There's symmetry in this big square. And what's nice about the big square compared to your tilted square?
That the big square is straight.
Big square is straight up and down and straight sideways, and the center is the same. So that tells you 4 minus 4. But you calculated it, so that's great. There was one other bit of interesting symmetry I wanted to ask you about. I wonder what it was. It wasn't about symmetry. Another equation you could have used to find A and B was the Pythagorean theorem. You knew A plus B was 8?
Yeah.
And you know A squared plus B squared is 40. So that was a different equation you could have used. Your way with the geometry and then subtracting out this area, finding the areas of these triangles was really good. So I just wanted to point out there was one other equation connecting that. A plus B is 8, A squared plus B squared is 40, and that would have led you down a path of finding some equations too. But look, I said we hadn't talked really about this. It's a very nice approach. A very nice approach. He's doing a section on rotations. And you see what happens when you rotate this about the center here? The point 4 minus 2 goes to 2, 4. And then where does the point 2, 4 go to?
It goes to minus 4, 2. And then
That point goes to?
minus, it would be minus 4.
Okay.
Oh yeah, that. Minus 2, 4.
Okay. Do you notice anything about those coordinates?
They all have 2's and 4's in them.
So there's some other symmetry going around here with rotations about the origin. So it's a very interesting problem. Very interesting problem. It gives you a hint here that there's something going on with these rotations that make the numbers not change that much and just have the signs flip around. The numbers flip and the signs flip around.
Yep.
It's interesting. But hey, that was a super job. Super job. Good work through that problem.